Okay, let's go ahead and solve for the V out of T of this integrator circuit. And a couple things we want to note is that in an ideal op amp, the voltage here is the same as the voltage here. So if this is 0 volts, this also has to be 0 volts. And we also want to note one thing, that the voltage across this capacitor is plus minus Vc of t, okay, where Vc of t is equals to 0 volts minus V out of t. So 0 volts minus V out of t. Okay, so Vc of t is simply minus V out of t. So now what I'm going to do is I'm going to use KCL, which tells me that the current going into this node I1 has to equate to the current coming out here, call that I2. So then using KCL, I1 has to equals to I2. I1 is going to be V in. I'm going to omit the T. V in minus 0 over Rn has to equate to the current across the capacitor is going to be that feedback capacitance, CF, and the change in the voltage across the capacitor, so Vc over the change in time. All right. But we know then that Vc is simply minus V out of t. So I'm going to write one equation here. So it's going to be Vn over Rn has to equate to CF, the change in minus V out over dt. In order to isolate this V out, what I can do is on both sides, I can multiply by this. An integral that gets rid of this d, this delta here. And then I can also multiply by a minus dt over CF. And what that does is the dt cancels this guy out and the CF cancels this guy out. When I multiply this entire thing by Vn over Rn, I get my final equation being minus 1 over Rn times CF integral Vn of t times dt is equated to V out of t. Thank you.